All right, so this is Radical and Rationals lesson 2. Start off with, we're supposed to be doing this where you just type the thing in, and then you type in the square root of that thing, and then you just check it. I'm going to let you guys do that. So if you haven't done that yet, fill these all in. Take the first thing, type in your graphing calculator. Type the second thing, type it in your graphing calculator. Or you could do this, y1 equals, for example, in this case, x squared, and y2 equals square root of y1. Then you won't have to keep changing your function 2. Just changing your function 1 will be enough to get that going. So if you haven't already done that yet, pause the video, go through, experiment, put the values in, see what you see. They even give you a fairly nice graphing calculator window. They want you to be from -2 to 2 and -2 to 2, or your zoom decimal will work very well for that. So you can go in here to your graphing calculator and go zoom decimal, and it'll get you a pretty nice window right there. And so I'm actually going to put this in, so x squared, and then I'm just going to put this one as, back to my y equals, down here, square root of y bars, function y1, close my brackets, and then there's the first one, there's the second one. So if I'm zoomed in like that, what I can see happening is that my square root transformation basically does this in that case. In this case, it's going to look kind of like that. In this case, it's going to look like this, or it should have. This is going to look like this, little McDonald's arch sort of thing. This is going to start at that point and then kind of go up. Eventually they'll cross, but not for a long time. And this one, there's just no graph. Here, this is going to look kind of like that. And this thing here is going to look like that. I didn't draw that part very well at all. It should look more like that. I should actually see the original graph underneath. So the domains are the same anywhere f of x is always positive. So if f of x is always positive, the domains are the same. And yeah, what we should have noticed is this. The graph ceases to exist when f of x is less than 0. And when x is 0, the graph lies on the original. If f of x is between 0 and 1, it is above the original. And the reason for that is that if we take the square root of a fraction, like a half or a quarter, the square root of 0.25 is 0.5. And 0.5 is actually bigger than 0.25. At 1, it's on again because the square root of 1 is 1. For values greater than 1, the square root of 4, for example, would be 2. So it's below the original. So if I was to plot this out, I'd have my points at 0 and 1 are all of the places where my graph is going to be intersecting. And I'm going to go above, through, and under. And anywhere where it's like a constant value, here it's constant at 4. I could do the square root of that value. Square root of 4 is going to be positive 2. So that would just be all the way across positive 2. Then it's going to start coming back down. And again, I should see the graph being over here. Let me see if I can make that a little more clear. Something like that. So the domain would just be between -3 and 16. Or again, I could go -3 is less than or equal to x is less than or equal to 60. X is an element of the reals. But because I'm lazy, I'm just going to use interval notation. Oh, shoot. Anyway, that's that. The square root of this is just x is an element of the reals. Or, try that again and actually draw a bracket from -infinity to +infinity, non-inclusive. The range would be y is less than or equal to 4, or from -infinity to 4. My range over here is going to be from y is between 0 and 2, or 0, 2, both inclusive. For these things, determine the range without sketching. Well, the initial range of this thing is that. If I took the square root of all of those values, what I'm now going to get is something where it's a little bit lower based on those pieces. That's going to get to a height of 3 because up here it's 9. Square root of 9 is 3. But they're all going to go down by amount. And the amount they go down is whatever the square root is. So this is now going to be y is greater than or equal to square root 3 for my new equation. This thing, the domain is going to change because it goes negative and negative. So my domain is going to be from -3 to -2. And then from 3 to 8. And that's it. So that's my domain, is those two pieces. My range is going to be, well, square root of 9 would be 3. So it's going to be y is between 0 and 3. All right. Yeah, perfect. Lesson 2, done.